Hi, Gutao. Okay, that's silly. Actually, that's also silly. This is probably just stupid what I'm doing here, but for division it wouldn't be stupid. So the why not reason. So I'm just moving A between A min and A max, and B between B min and B max, and then we find out what is the minimum and the maximum of that product. And the expectation is that it's going to be one of four possibilities. Let's just make an array with those possibilities. So might as well fill it immediately, I think. Probably just one of these, right? But even though it starts at a min, it's not necessarily running up till and including a max because of the 0.1 floating point round-off errors. So instead of running till a max, where a max is a min plus a multiple of 0.1, let's do less than a max plus 0.05. I think that should work. So now the largest value should be almost equal to a max and b a max. So these, yeah, I could do power of 2. Maybe I should do that. Yeah, okay, I'll do that because it's just the round-off error stuff is really shitty. Let's make this 16. So run between plus or minus 16, and it doesn't really make much sense to go way all the way to the top here. I think it will, any integer value would still work. So 15 should work. And I'm going to change 0.1 into, oops, 1/8, I guess. 0.1 becomes 0.125. These are now exact, are they not? I mean, integer is exact, and then we can add 1/8 to that. That should still be totally exact. I think they should be exact. And then even the product is going to be exact still. Pretty sure about that. Well, since everything is exact now, we should be able to assert that both a min and a max are equal to one of these four. So you can do assert I'll just run over it. Guess for int I equals 0 to I is less than 4 plus I. If a min equals candidates I brick. So if we ever reach this break, then I is going to be less than 4. Otherwise, it's going to be equal to 4. Could do the same thing for, I'll just use J or something. ZJ. In other words, both AB min and AB max will be one of these four. But we'll begin with that. That's probably going to be working. Why is it so slow? Did I overdo it? A quarter is 8 times 20-ish? No, 16. 32 times 8. 128. Per loop. It is 128 to the power 4. Okay, that's a lot. Well, 268,000. It's not that much. Yeah, I'm surprised that the text is long. Let's print something. See if any progress at all. Bmax is Bmin, Bmax, Bmax is that, Bmin, Amax, looks good. Okay, definitely runs there. Okay, that's definitely slow, yeah. It takes a long time for even this loop to finish. And then it's gonna take the size of this loop times 128 times as long as that we have to wait now. If I waited till the end. It's hours or something, close to an hour. And it's getting slower and slower also. But Yeah, there was no need for anything actually. But if this works, I'm gonna assume that the inner loops are not necessary. Whoa, just changing a factor of 2 really makes a big difference. How much slower did it now get? I don't know, 64 times slower or something? Could take a few minutes. I already saw enough. Okay, so this holds. We don't have to loop over all values of A and B. It's always going to be one of these 4. So instead of doing this loop, we're just going to say AB min is the minimum of these one of these 4. Yeah. Missing header or something? Right, well that was faster, so we can make step smaller again. Let's try the 1/8 again. Yo, still super fast. Now, what is the next thing? So this is the range. Maybe I should now figure out which of the 4 possibilities it is actually. I want to have the index, so instead of doing this, I'm just going to set it to candidate 0, and then int maybe min index or something 0. Now, I'm pretty sure that if both A min and A min and B min are positive, then this is, well, this one is always going to be 0, and this is always going to be a 3. So let's just for fun start with an assert for that. So here we could do assert. But this then only holds if this is larger than 0 and this is larger than 0. And that is true. Yeah. Now, because these are booleans, we have basically 16 possibilities. Well, yeah, not really 16, because it's not possible that B max is less than 0 and B min is not. It's more like 3 to the power 4 possibilities. We just pick one possibility. Let's say if A min is less than 0, but A max is larger than 0, and still B min is larger than 0, then we have just one of those possibilities, and I'm pretty sure that in that case the indexes also should be fixed. So we just print them. I suppose I should get the same numbers all the time. Or not. That looks like very much 1,3 again. What? No, 1,3. Before we had 0,3. Yeah, no, I think so we have only 3 possibilities for A min and A max. Both are larger than 0, or min is less than 0 and max is larger than 0, or both are less than 0. Yes. They can also be equal to 0, by the way, in which case it's probably doesn't really matter, so we can get just randomly one of them. So let's just not test it. And this is not going to be true. I'll have to print them again. That looks like 1, 2. And then of course we have the same thing, but then we do the stuff with bmin. Yeah, no. We'll do the same thing again, but then with bmin less than 0 and bmax larger than 0. And then again with both less than 0. So yeah, that's 3 to the power 3 possibilities then. Which is 27, which is a bit much, so maybe we can automate this. Let's call it a category or something. So int a category is call that 0, otherwise call that 1, otherwise it must be this one, and we call that 2. It's not hard. What is hard about this? So what I now want to do is, if we discover a category that we did not see before, then we store these two values. And if we did see it before, then I want to check that these values are the same. And theoretically, it would be easiest to use a standard set for that, right? But only if you know what you're doing. It's dubious here. Let me think. Normally I would use an array, really, but then you need a to being set or not set. I want to store two values which are blah blah blah. Okay, I could use -1 to signify that I didn't see that yet. No, I don't know, man. Gonna use an. I'm going to use. I'm just making a static thing here. Oh my god, array, yes. Of a pair of ints. This is ridiculous, but okay. 27. Table. So we have 27 pairs of 2 ints, and since it's static, it's going to be filled with zeros. So we have to fill, if you fill something in and want to always see that it was now filled in, then it must be filled in with something that is not 0, 0. Annoyingly enough. So we're going to do if table category dot first equals 0. Just look at total. I don't have any 0 in it at all. So if the first int is a 0, then it was not initialized. Then we just initialize it for the first time. So we set first equal to the min index. Hell. I have a min index that runs from 0 to... It's not true. What is min index? Min index is just an index. It's indexed into this array. Let's make run from 1. So it started 1, 1, 2, 3, 4. But of course, the real index started 0. Okay, what shall we do? I just increment it afterwards, I suppose. So now they run from 1 till 4. So we store 1, 2, 4 here, and then therefore the next time it is already initialized, and then we can do assert the min index must be equal to what we did store the last time. In other words, this makes sure that if the category is known, then we also know what the min and max index is. They're always the same. Which then means that, let's first run it. Don't crash on me. Fuck. It's in the title, the problem. Title of the video. No, damn it. Am I coding something wrong, or is it just not true what I assumed? I need more debug output. So this is the first encounter where a category is a category and B category is B category, and therefore category is category. And then we have the AB min index. AB min index. And the AB max index is AB max index. And then if this fails, if not that, so the assert is going to fail. Print the same thing shit, I guess. That's not really helping, is it? You have to be able to check that this is correct. One more. I don't know. Oh, really? That's got weird, isn't it? It's more like 16 times 16, if you ask me. Yeah, what? Yep, this is not what I had intended. I just want to do something quick. That's why I would do it brute force. Since it happens pretty quick, might as well just print a shitload of output. I think, because yeah, well, it happens in the beginning. So this total amount of output is probably not going to be very big yet. So I just print all the for loop values. A min, a max, b min, b max, b max. Okay, now we have all of those. I'm gonna just add some function to do this. Show whatever. I want to print the index. And I want to have all these values, of course. Shit, isn't that it? Did I not already do this? It's just all of this shit, isn't it? Yeah? Yeah, it's not Amin times Amin. Dude, this is it, yeah. We print that here. I don't understand this. So bullshit. Doesn't seem interesting or important, but A min is minus 16. That's where we begin. A max is just a step higher. B min minus 16, B max is a step higher. Then we calculate, or what are we doing here? Yeah, calculate 4 times the 4 different possibilities. A on one side, B on the other side, min min, min max, max min, max max. Thus, yep. That looks like correct. And now we're going to find out what is the minimum of the product, A times B. It would be this one, right? candidates is less than AB min, and it is, AB min becomes candidates I, which is now 254, and the index becomes 1. Then we do the next one. This is not true because 254 equals what we already have. But this is true again. To now we set it to 252, and the index is set to 3. And then we increment it. Now the index is set to 4. Print it. This was printed 4. And then we call show. And that 4 refers to this, the last one in the array, or max times max. Then we go into show, switch AB min index, and then we end up here indeed with 2 maxes, and we print the min. I found it. Max times min. Max times max. So now we say that AB min, aka the smallest product that you can get, that is the that is really the smallest one, but everything is negative, so we're going to always multiply two negative numbers, giving a positive number. So the smallest product is going to be this one times that one. And yeah, that's 252, which is less than the 254 or the 256. That are the other possibilities. And this belongs to index 4, so yeah, minimum is 4. The maximum, of course, is going to be then the 16 times the 16, which is index 1, which is minimum A min, B min, multiplied, which is indeed the largest value, 256. So I totally agree with this. No errors there. And then the category is being calculated. How did I calculate the category again? That is cat. Why was A cat 2 and B cat 2 as well? I forgot. If these categories are both 2, then the total category is 3 times this one, I think, plus that one, so that's 8. Category runs from 0 up till 9, so the 8 is the largest value. And apparently then with this category belongs these two values, assuming that it is only a function of the category. It prints this again, which is the code that I was copying, which is still wrong. That's probably not necessary to print it. But okay, here we're filling stuff in. I think this is filling its stuff in. So it would be nice if you could check that. Yeah, this is just a min. So I already have that information now. Maybe just let's not print it there. category means, oh yeah, which one is less than or larger than 0. So if both are less than 0, that is not true. So we come here and then this is also not true, because this one is less than 0. So if both are less than 0, then it's category 2. And category 8 would be everything is negative. So yeah, that's there. Yeah, okay. I'm printing category here already, just with failure in front of it. I think this is the reason why it goes wrong. In the case of 0, I just get a random thing. So I get something which is unequal to what I had, but what I had is also okay. I think I should just skip values of 0. I think that will solve this problem here. So they just can't check the sign, and it is 0, giving all kinds of problems. Yeah. And now we have too much output again. Probably I do want to see these two things. I might as well print this down here. And we might as well print all of that. Oops, I've got something. Let's print this only here and here. And then also have to get rid of these values. Uh-oh. Well, it fails again. Okay, A min is minus 16, max is an eighth, and B is the same range. The minimum value that we can get that way is a negative value, and well, yeah, we only have minus 16 and minus 16, so it's just going to be minus 16 times 1/8 is minus 2, and the maximum value is minus 16 times minus 16. So I agree with this. And indeed, index 1 is A min times B min, and 2 is A min times B max. So then these are the two indexes, and we store those here. Under category 4, which is 2 times 1 plus 1, 3 times 1 plus 1, I mean. And these two are both category 1 because yeah, because the minimum value is negative and the maximum value is not for both. So negative and not negative means category 1. So this looks completely sane. Then why is it going wrong here? Now here we have minus 16 times 1/4. Minus 16 times 1/8. So the only thing that changed is the maximum value is now 1/4. And now, that's the reason. Yeah, interesting. So now minus 4 is the smallest value because we have to multiply, we have to use the quarter to get it big. So minus 16 times 1/4. And in the previous case, it didn't really matter which one we picked. Could multiply this one with that one, or this one with that one. Okay, bottom line, let's not store something when it is not unique. I think that's still going to fail, but at least that will be a little bit more clear then. No, that's not what I expected. It finishes, but it is only printed once. What the hell? Why? It should immediately print something. Well, maybe not immediately, but pretty damn fast. Break main. No, A and B are doubles. I think this is not correct because I think we find one of the 254s. Yeah, should have paid more attention. Let's put a breakpoint at 16. Run it again. What kind of bullshit is this? Oh, wait a minute. I already said it here. Never mind. So this thing is set to index 0, which was 256. And then the next one is indeed smaller, because that's 254. So now we set AB min to 254, and remember the index 1. And then the next index is also 254. So I is not unique. Okay, unique is false. But now the next index is less, which makes it unique. I think I should set unique here. 6, 7. See, if it is less, then we start over, kind of. So I just have to set it to unique is true again. And then the other unique can't belongs to the fact that we just set these things. Let's put it there. Yeah, as in AB min index, unique. AB min index, unique. Start over. So only if the one that we find here, the one that is actually the minimum, if that occurs twice, then unique is set to false. No, the same thing here, of course. Now it started at least printing immediately, but it asserts. the hell? Okay, so it's not true. It ain't true. The category is not enough to decide. Hello, Johnny. I think you have to look at both the sign and the absolute values. So it's really a whole mess of compares. Starting to think I should just calculate all four. And then pick the smallest and the one and the largest one. Yep, I think that's what I'm going to do. I still don't have any insight though. I mean, really, how can this problem be so hard? It looks so simple. It's amazing. I bet you can visualize it somehow. And then it will maybe make sense. I still don't see it. I think I'm just stupid. I have the feeling, however, that maybe this error only occurs if both A and B cross zero. So this is negative and this is not negative, and here as well. If we ignore those cases, then it might work. In which case I would only have to concentrate on this single case where this is negative and this is positive and this is negative, this is positive. To figure out the rest of the remaining part, as it were. So let's try that. So once you get here, just like the unique, might as well do it here. So if a min is, well, that's kind of the category then. If a min is not larger than 0, but less than 0, and a max 0, so it's category 1. And I was saying both are category 1. Yes, so that would be category 4 would be the only one. Seems so far-fetched. Okay, so if category 4, then continue. Just don't do the test. How can this be so slow? Wait a minute, let me try this. This also hardly makes any sense. If only category 0, 1, 2 and 3. And 4 I skip. Where are category 5, 6, 7 and 8? It's not possible that we would not encounter those. In my opinion. Yeah, so that means that what? I do have a category 2 here. This isn't even symmetrical. Talking about complete impossibility. There is no difference between A and B, so it should be symmetrical in A and B. So if you see category 2, A category is 2 and B category is 0, then there should also be A category is 0 and B category is 2. But you don't see that, which is a clear indication of some kind of bug in my program. Yeah, I'm going to bed because it's time to go to bed. I'll be back tomorrow. In the meantime, I would say if you want to do something fun with with C++, figure out this problem. Yeah, it's in the topic. So you have just 2 doubles. And the only thing you know is that one double is in a certain range, so between a minimum and a maximum value, and the other double is also in a range between some minimum and some maximum value. So I call them A min and A max for A, and B min and B max for B. Doesn't matter that I give them values here. That's the given. You have some value for A min and A max, and of course A max is larger than A min. The only thing you know is that I have an A that's in this range between an A min and A max, and I have another one that's B, which is in this range between B min and B max. And then I'm going to multiply them. What is then the range that the product will be in? So what is the minimum possible value and the maximum possible value of the product? And I already figured out that that is going to be one of these 4, both of them. So this could be the minimum and that the maximum, or this could be the maximum and that the minimum, or this the minimum and that the maximum. It just, just so you have like 4 times 3, I guess. No, 4 times 4 maybe. Nah, not impossible. If you take twice the same thing, that's not possible. Or maybe 12 possibilities. I don't know. Now, how do you figure out which possibility it is? What is the minimum of the product and what is the maximum of the product? So I thought I'd just write something brute force, where it runs over a wide range with a small step going from negative to positive, and I do that for both. Now the maximum value must be larger, so it's A min plus a little bit, and then we just calculate it and see what happens. And it is still not clear. Okay, I'm going to bed. Have fun.